Okay, let's go through a few problems on 6.7, name that graph. Now, what you're going to have to do is for each graph, find an equation both in terms of sine and cosine that represents the graph. And so a few things to note is, actually, let's just start by the easiest thing, doing the two things that are easiest to find, which are the amplitude and the vertical shift. So the amplitude we can always find by doing the highest value minus the lowest value over 2. And the amplitude here will be 4. So if I go 4 away, so that means from my midline, I'm going 4 above and 4 below. So which makes my midline will be at 1. So that means the vertical shift is up 1. Okay. So here we go. And so normally sine starts on the midline and goes up. So it looks like the sine graph would start here. So it looks like it's been shifted to the right if we're talking about sine. In terms of cosine starts at its highest point and then goes down. So it looks like the cosine graph, here's where the cosine normally would start, up at the highest point and going down. So it looks like cosine 2 has been shifted to the right. Well, and I seem to know how much let's do cosine first, because it looks like we know that the cosine graph has been shifted to the left 7 pi over 36. Well, in order to write that in the proper form, we've got y equals 4 cosine. Now, remember, normally it would be bx plus c, but if I know the vertical shift, or to reflect the vertical shift, I'm going to write it like this, which is a little bit different. Because what this means, and then of course I have up 1. When it's in this form, it means, okay, after taking into account the period change, which is that b value, then I'm shifting it over c. So in this form, I can put in the horizontal shift as 7 pi over 36. It means, again, after I take into account that the period has changed, I'm shifting it, in this case, to the right, 7 pi over 36. And I'd use this form if I actually know that shift and I have that highest point, or I have some other point that actually gives me the exact shift. Well, turns out we can also find the b value here decently easy. Notice from this high point to the low point, well, from the high to the low point, the 2 points I've been given, that's half a period. So half a period then is going to be equal to, well, the distance, the horizontal distance between these 2 points. So 19 pi over 36 minus 7 pi over 36, which is 12 pi over 36, or pi over 3. So if that's half a period, then it means a period is 2 times that. So 2 pi over 3. And remember how to find the b value. It's going to be 2 pi over the period. So in this case, 2 pi divided by 2 pi over 3, or 3. Okay, so now we really have all we need for the cosine function that is represented by this graph. So we've got 4 cosine 3 parentheses x minus 7 pi over 36 plus 1. And oftentimes we write it distributing that 3 inside the cosine function. So 4 cosine 3x minus 7 pi over 12 plus 1. And remember, once you have one function, I can, meaning either sine or cosine, I can get the other by doing using the fact that they're cofunctions. So to do the sine, I would just say y equals 4 sine 90 or pi over 2, because we're working in radians here, minus 3x minus 7 pi over 12 plus 1. So y equals 4 sine, okay, so pi over 2, it's going to be minus 3x. Pi over 2 plus 7 pi over 12 is going to be 13 pi over 12. But as I mentioned before, the convention is to have the coefficient of x be positive. So we're going to factor out that a negative. And that's going to be 3x minus 13 pi over 12 plus 1. And remember, sine of a negative angle is equal to negative sine the angle. So negative 4 sine 3x minus 13, pi over 12 plus 1. So we've got our cosine function and then our sine function that represents that. So this is somewhat of an easier problem in that we could get b and get the horizontal shift by the 2 points that were given. That's not always going to be the case. So in the next video, I'm going to walk through, well, what happens if we can't actually do that? What do we do there? Okay, so stay tuned for the next one.